Hello everyone, this is Session again, and today in this tutorial we will be talking about load balancer. It's going to be a hands-on session where we will see how to create load balancer, how to associate with the auto-scaling groups, and we will, in theory, we'll talk about the scaling policies as well. And lastly, the stickiness of sessions. So let's get it started. Okay, so basically, you logged into your AWS console, and you can see right now I'm in a Singapore region. So this is the place where I'll be creating all the infrastructure. So let's go to my load balancer. All right, create load balancer, and there are multiple type of load balancer. Classical is like which was previously used. It's not recommended by AWS. ALB is like application load balancer. Basically, it's a layer 7 load balancer, which means it can inspect your URL headers, path parameters, query parameters, all that stuff. So it can take decision based on that. ALB is a layer 4 load balancer, so basically it doesn't have that flexibility. So basically it's like based on IP port, that stuff. It doesn't read your parameters or payload or header or something like that. But ALB is very fast compared to ALB because ALB has to do inspect your headers and all that stuff. So I'm gonna create application load balancer. Just give it a meaningful name, my ALB, something like that. I'm going to be placing it at an internet facing because you can make it an internal as well if your internal application within a VPC wants to load balance between your EC2 instances. But in my case, I'm gonna make it an internet facing. So it's an IPv4 based. Just keeping all the configuration default one. So we'll go to a default VPC. I choose the subnets. So basically, whatever subnets are available, you can actually choose where this load balancer will be placed. So basically, when you create load balancer, this is a single logical view from our perspective, but internally, the number of subnets you choose, there will be a load balancer internally will be created and the load will be balanced within that subnet. But that is like totally abstracted away as a developer, and we just create a logical view of one load balancer. But please remember, internally, a single load balancer will be placed in every subnet, and that's what you are choosing here in the subnets. So right now, like I want to place my load balancer to be created in A and B and leaving the C. There's no reason. You can choose C also. I just want to keep it for now in these two subnets. I just go with the default security. Basically, if you see the default security, it allows SSH port 22 from anywhere, and also it allows to get the request from anywhere for port 80. So that should be good for me because I'll be accessing it over HTTP. Okay, this is listeners and routing. So basically, this load balancer listens on port 80, but there should be some kind of a target group where the request actually will go. Right now I have no target group, so let's create one. All right, so my plan is to basically create multiple EC2 instances, deploy small dummy applications, which I can make a curl call or REST call and get some response. So eventually it will be instances, so I'm just leaving it a default one. I'm going to give it a name, the target group. So let's say my TG stands for target group. And the application which I will deploy will be an Nginx application, and that will also listen on port 80. So that's why I'm leaving it as it is, port 80. It'll be in default VPC, HTTP1 should be okay. Health check, I'm just leaving all the default options, though you can actually put some kind of a advanced health check settings. You can modify these according to you. For this demo, that should be okay. Next. Perfect. So ideally, I should be creating, let's say, manually instances over here. But my plan is to associate it with auto scaling group, and that's why I'm deliberately leaving this section. So eventually, right now at this stage, there will be a load balancer, but there won't be any target group. There's no place or no EC2 instances where the request will actually go. So this seems like not a right thing, but this will be very clear when I will go to auto scaling group, and there I will associate it with this load balancer. So auto scaling group and load balancer will work hand in hand, and ASG, which is auto scaling group, its responsibility is to maintain that many number of EC2 instances based on load or whatever configuration you have given, and load balancer responsibility is to distribute the load into these instances. Please remember, at least this was confusing for me initially when I started learning about load balancer and auto scaling group. Remember, when you create for this setup load balancer and auto scaling group, when you're creating a load balancer first, you leave this instance not required over here. Just to reiterate once, create target group. So my target group is created. So I go back to my load balancer and I refresh this once again. And when I click, I can see my target group is created. So this is the association being created. All right, just leaving everything optional and create load balancer. Of course, my load balancer is created. And I come back to my ALB, and then I got a DNS name. Of course, if I click it, I won't get anything because there's no instances over there. It's not useful as of now. All right. If you want to choose what configuration you have done, you can come to the listener, and it listens to ETI, and it the rule, or it forwards to my target group. You can click it and see that details what you have configured. All right, so this is the load balancer and target group. Now let's come to auto scaling group. So now you want to create an auto scaling group which will maintain a basic number of EC2 instances where the load balancer will distribute or load balance the traffic. So let's get it started. Create auto scaling group. I'll just call my ASG as for auto scaling group. See, whenever you are creating an auto scaling group, of course, it will be managing the instances, what all instances it needs to auto scale. And definitely you need to give some kind of a launch template or launch configuration. So in my case, I'm just using a launch configuration. I have none right now. So let me create one launch configuration. Okay, I'm just saying my LC stands for launch configuration. AMI. So for my thing, I have a pre-baked image which has an Nginx installed, but in your case, you can use whatever CentOS or Ubuntu-based image, manually install stuff. But just for this tutorial, I've already created this particular image, which is my, it's in my account, so it won't be available for you. But feel free to take any CentOS or Ubuntu-based, or like whatever, as long as you make a call and it can give you the response. So I'm choosing this one. Instances type, just want to keep things simple. I'll just say T2. Okay, choose T2.micro should be okay for this. Micro, yaps. All right, so in this instances, which has the 1 vCPU and 1 GB RAM, this image will be created. All right, I'm just leaving everything default. Select an existing, just choose whatever security group. For now, for this demo, I'm just keeping an unsecure, which allows everything from everywhere. Of course, this is dangerous for production. Nobody should do that, but this is just a demo. All right, I'm just choosing a key pair. I already have a key pair created. Acknowledge and create launch configuration. All right, now my launch configuration is there. Now the only thing left is to create an auto scaling group. Now create auto scaling group. I'm just going to say my ASG stands for auto scaling group. Launch configuration, and now my launch configuration is available over here. So there are multiple steps. So first time, just to reiterate, I'm creating an auto scaling group after giving the name and the launch configuration. Launch configuration with the name clear. What is the configuration which this guy will be launching, basically the EC2 instances. What is the VPC and in which subnets the instances should be placed. So here also I'm just choosing A and B, just leaving the C. There's no as such any reason, but just to demonstrate when the instances will be created, they will only be into these subnets. So go to the next one. All right, this is an important step. So basically, remember when we created load balancer, deliberately we did not associate it with any instances because we were planning to create an auto scaling group and then associate or attach this load balancer. So I'm going to choose attach to an existing load balancer. Okay. Of course, it's not a classic load balancer, so I'm just creating, associating this target group, the existing load balancer. Okay, just leaving everything default. I don't need a metrics for this demo. And next, okay, desired capacity. So I'm going to put it, let's say my desired is 3. Minimum, it should not go less than 2, and it should not go beyond 6 to save on my cost. Scaling policies, basically, as we will just talk about theory over here, but you can apply some kind of a scaling policy. So this is like your minimum 2 and in a default or desired capacity, but you can say, okay, if my CPU usage goes beyond a certain limit, then add 1 instance. So this is called scaling out policy. Similarly, if it goes below some range, you want to reduce your instance, save on your cost. These are scaling policies. For this demo, I'm not going to do it, but just to let you know some theory around that. Choosing it none. Production right now it should be okay. Next, I don't need any tags. Just quickly review this VPC availability zones. It's my ALB, this target group 2, 3, and 6. Create auto scaling group. Perfect. So at this moment, you have done all the 4 steps. You created load balancer associated with the target groups. Basically, you haven't associated any instances, but at the time of creating auto scaling group, you have associated it to a load balancer. So that should be okay. Let's click it and click on activity. All right, so now you see there are some activities hoping. Basically, there were 0 instances and it has to reach to 3. And so you see these 3 events. Let me go in the meantime to the Ec2 dashboard and see the instances 0 running. Let's refresh, 0 running, cross it, refresh. Okay, so there I see 1, 2, and 3 are in pending state. So let's refresh it. Why 3? Because this is the 3 desired capacity we have given. All right, I'm just choosing one. This is the public address. So my intent is to go to individual instances and just check or start the Nginx. So you can hit it and see the response over there. So SSH Sachin is my username. As I said, it's my pre-bed image. I can SSH to this. I'm already authentication all set up, so I don't have to do any passwords or anything. I can just directly go inside the box. So its private IP is 172.31.20.174, which you can see over here, matches here. So basically I'm in a right box. I have a scripts already in the scripts folder. So scripts and then run Nginx. Okay, this will run an Nginx over here. So which means if I take my public IP and if I hit here, I will see the private IP printed over here. Okay, so 174. So the Nginx is running the first one. Let me go to the second one also. Do this. So if you see previously, it won't run because I have to manually start it. SSH. Let me exit. SSH. Session will follow the same step over here. Script Nginx.sh. Exit once again. Session @ and finally the third machine as well. Okay. Script run Nginx. So Nginx is running in all 3 machines, which we can validate. We check the first IP and we can see it is printing the private IP 174 ending. We go to the second machine, take the public IP, do this 16.50. It's printing here. By the way, in a real production case, of course, you will not expose your EC2 in this port. This is just a demo and to quickly validate that Nginx is running in each individual machine before testing the load balancer. So this is just a small workaround to do it quickly. But of course, you will not expose the whole purpose of load balancers. That will be the only internet facing, and these will be instance will be in your private subnets. Okay, 233. So all the machines are ready and Nginx is running over here. Now we just need to check whether the load balancer is working or not. So you go to load balancer, you have a DNS name, copy that and come here and enter. All right, so we can see this is working and it has gone to 174, which is basically one of these machines. So let's quickly check that. 174. Okay, so this has gone to the first machine. The other IPs ends with 50 and the last ends with 233. So let's remember it ends with 174. Keep refreshing it and it does go into all 3 machines. You can see 233, 50 and 174 is doing a round robin manner. I'm just refreshing it and you see the load is going into all the 3 machines. All right, so before winding it up, let's quickly see the sticky sessions as well. So I'm just in the load balancer. I went to target group, click on this, and here you can see the healthy instances and unhealthy and so on and so forth. All right, if you go here, okay, if I go to my target group and edit attributes, now here you see the algorithm it uses is the round robin, which means in this target group, which is currently 3 machines, load balancer will use the round robin fashion to distribute that load. And that's what we have seen here. Like if you click it every time, it is doing in a round robin fashion. But sometimes you might have a requirement that you want a stickiness, some kind of a stickiness where you from your browser, if you're hitting that load balancer, the next time it should stick to the same EC2 instances rather than going in a round robin fashion. Maybe you are maintaining a session with server or something like that. So you click on stickiness and then it says load balancer generated cookie. In this case, basically it will use the AWS cookie, and we'll quickly see in a moment, and the duration. I'm just leaving everything default and save that. So what it means, the stickiness is now allowed, which means if I once again go to the new tab, press enter, let's say it reaches to 233. I keep refreshing it. Okay, maybe it is still applying the stickiness. Yes, so now it is there. So the request reaches to 233 and I'm refreshing it. It doesn't change. You can see this changes, but this IP is not, which means the request reaches load balancer. Load balancer somehow, and we will see that in a moment, understands that this request is coming from the same machine and make sure that it lands to the same EC2 instances. Until and unless there is some problem in that instance, let's say it has destroyed something, in that case, it will move the request to another machine. And then from that point of time onwards, it will continue doing that. So we can, sorry, save. So we can go here and check in the cookie section in the ALB that it stores a cookie over here. And when the new request goes, it uses that cookie. And that's how load balancer understands from where this request is coming. It makes sure which, whatever instance was previously served, it lands to the same instance. So basically, if I just go ahead and delete that cookie, there's no way for load balancer to understand that, from where the request has come, because it will be a like fresh request. So if I hit this time, randomly it will choose a new EC2 instance, and then in the response it will send the cookie back, which browser stores it. Now next time when the request goes, again this cookie will travel in the request, and then load balancer will understand, okay, the EC2 instance ending with 174 has served it previously, and the request lands to the same one. So now if you keep refreshing it, it will keep to the same machine itself. So that's about stickiness. I hope you have enjoyed it and learned something new. If yes, please like and share, put your comments or anything, suggestions. Maybe I can create more videos like that in that case. Thank you.